Stratospheric Aerosol Injection, or SAI, is a promising approach to help cool Earth. In partnership with Reflective, we just released a new climate simulator at planetparasol.ai that you can run to explore the potential effects of SAI deployments. SAI would mitigate global warming by using reflective particles to reflect, say, 1% of incoming sunlight and thereby cool the planet. Reflecting 1% of sunlight will lead to around 1 degree Celsius less of warming. Without SAI, there is no longer any plausible path to keeping global warming under 1.5 degrees, and it looks all but certain will blow past 2 degrees as well. To address this, we should take SAI seriously as a possible tool to complement decarbonization. The simulator is built in collaboration with Dakota Gruner and her team at Reflective, and climate scientists Dan Vizioni and Douglas McMartin from Cornell, and Duncan Watson-Paris from UCSD. It lets you explore how different implementations of SAI might influence temperature and rainfall.
The tool uses a simple climate model to see the potential impacts of different SAI strategies on global and regional scales. Now, it's important to note that while climate models, including this one, are important tools for understanding past, current, and future global climate variability, they are not able to provide perfect predictions of the future. So the results here should be seen as probable futures, not guaranteed outcomes. But here's an example of a plausible scenario. We've assumed moderate emissions reductions, the middle of the road scenario, now seen as most likely. And we've also set a target of limiting warming to 1.5 degrees Celsius, consistent with the Paris Agreement target. And we've set the simulator to start deploying SAI in 2035. In this initial view, we're looking at temperature. What you can see in the chart on the right is that temperatures would continue to rise without SAI, the red line, while in the blue line, the SAI scenario, we've held temperatures flat. The map on the left compares regional temperatures without SAI, shown on the left side, and temperatures with the SAI scenario we've defined, shown on the right. You can move the slider back and forth to see how things differ between these two scenarios. As you can see, in this scenario, we can cool the planet relatively evenly, bringing us much closer to pre-global warming temperatures through the use of SAI.
You can also change the plot to show a histogram of temperatures around 1950 compared to future temperatures without SAI and after applying SAI. You can see that SAI doesn't turn back the clock perfectly, but it brings us much closer to pre-global warming temperatures. However, only looking at temperature effects does not tell the full story. You can also change the impact to plot. Let's try looking at water availability. As you can see, there's less rainfall of SAI, since a cooler planet means less moisture present in the air. And the regional effects from cooling are not uniform, just like the regional effects from warming have not been uniform. Some areas have more water, and some have less. For example, in this region in South America. We can click on this region in order to change the plot on the right to focus on that selected region. As you can see, water availability is projected to be lower in this region under SAI. This is why we work on tools like this, to help us navigate what could happen if society were to implement SAI.
SAI is a promising tool for mitigating global warming, and AI climate modeling will help us better understand how it would affect our planet. The results we're getting from these models are making me feel more hopeful than ever about finding a path to address global warming. Have fun playing with the simulator at planetparasol.ai, and please help spread the word about SAI.